In some of the earlier videos, I've shown you how you can combine your normal standard sine of x graph, how you can combine your normal standard sine of x graph with your y equals x graph. You can combine the two to give you a sine graph where the amplitude keeps on increasing. But suppose there's something in nature where well at the moment our y equals x sine of x. It's increasing by a not so much amount. But suppose there's something in nature where you want to model it so that it increases by let's say y equals x squared. There's no reason why you can't combine y equals x squared with sine of x. So for example, hang on. So for example, our normal sine of x would be like this. Well, the y equals x here places a border on your sine of x here. So the limit is your, well, it places you within a boundary here. Okay, there's no reason why you can't have it like this. Hang on, your y equals x graph will look something like this. Y equals x graph, sorry, y equals x squared will look like this. Hang on, y equals x squared will look something like this. Y equals x squared will look something like this. Okay, it increases a lot more than your y equals x graph. Your y equals x graph will just be a straight line, whereas y equals x squared, it will get bigger by a lot more. Now looking at your sine of x, your sine of x is something like this. Now with y, so here you've got your y equals x squared here, and then you want to combine it with y equals sine of x here. Now looking at this here, looking at sine of x, so now we want to investigate y equals x squared times x times sine of x. So really we've got this block timesing with this block here. Now looking at your sine graph, is this block here would be here, will be here. Well, it would be between -1 and 1, and when you times it with x squared here, it would take you to here. And this point here is 1. On your normal standard sine of x graph, it would be 1. It would be 1 at this point here. Now you then, so at this point here, the sine graph will be at 1. Well, at this point here, the x squared will be right here. So 1. So this bit here is just the number 1 times this bit here. It will take you to here. Okay. So from here you would jump to here, and then at 0 here, at this point here, sine of x will be 0. 0 times x squared, whatever it is, whatever timesing this 0 here, it will be 0. So at this point here, it will be 0. So at this point here, it will also be 0. So here your graph will look something like this. Okay, and then this point here, looking at your sine of x here, it will be negative 1. And then your x squared, it will be well, your x squared value will be here. So when you get -1 times x squared, it will be this distance here. But because you've got a minus here, then you're gonna in a way invert it, but with this magnitude. So it's going to be somewhere down here. So your graph will look something like this. Oops. Now this point here is 0. Okay, so it will look something like this. Okay, and then earlier we worked out that this is positive 1, and then when you times it, it takes you to here. Okay, so here, and don't forget this is 0 here, so it will be like this. So it's increasing all the time. This point here is positive 1. When you multiply it by x squared, it will take you to here. And this bit here is 0, so it will always be at 0 here. So your graph will look something like this. Okay, and then looking at this point here, it would take you, looking at this point here, it would take you to all the way up here. This bit here, this bit here is 0. This bit here is 0. So your graph will look something like this. Okay, now looking at this here, hang on, let me clear this. Bear with me. So look down. Let me just draw this in. So looking at this bit here, it's -1. Now -1. Well, how we are trying to investigate this. Y equals x squared times this here. Looking at this point here, this would be -1 because look, it's on the negative side. This is -1 here. And then you times it with x squared. X squared would be this would be up here. So ignoring the sign at the moment, it will be this magnitude here. It will be this magnitude here. But then when you take the -1 into account, then it's going to get flipped, but with this magnitude. So it will be somewhere. It will be somewhere down here. It will be somewhere down here. Okay, this magnitude here, the magnitude here, is the same as this magnitude here, and the reason it's being flipped is because of this -1 here. Well, anyway, this point here will get moved down to here. So this on the negative side, it will look something like this. Okay, same reasoning here. Look, with this magnitude here, this gets flipped, so it's going to be somewhere around here. Okay, so 0 here, it will look something like this. Let me just remove it. Let me just remove this. Let me just remove this. Let me just remove this here. You see, let me just remove this here. You see, it's getting larger and larger here. Okay, but it gets, the amplitude increases a lot faster than your normal x sine of x. You see, with your normal y equals x graph, it would be like this. But with x squared here, you're forcing the sine graph to increase a lot faster. Okay, so yeah, so in the next video we will look on the negative side, but on the positive side it will look something like this. Okay.